Yeah, go ahead.
Yeah, the volumes are two types basically. So one is persistent volume and another one is stateful. So why we volumes came into the picture? So
Mm-hmm.
when pod is getting deletes, for example, okay,
Mm-hmm. Mm-hmm.
so the whatever the storage of the data will loss automatically. So
Yes.
to
Yeah.
overcome that data loss, when the volumes implementation came to the picture, so here stateful and the persistent volumes. In the stateful, for each pod, the dedicated volume will creates like EBS volume.
Yeah.
For persistent volume, so the data storage will shares for the each pod. Like one EBS volume can use for multiple nodes.
Yeah. Yeah. In the deployment.
Yes.
Yeah. Deployment.
Deployment values actually. If you use in deployment, if you use values, it will behave like that.
This is the shared volume. This is the dedicated volume.
Dedicated.
Yeah. Okay, good. Nice. So from where the volume will come? Let's say, for example, one minute. Yeah. So
Yeah. Deployment, pod, stateful, daemon. Stateful set, daemon set. Yeah.
there is one more line. Concept, right?
Cron job.
Can you tell me some samples of daemon sets?
Yeah. So monitoring agent tools, logging agent tools.
Grafana and Prometheus.
No, those are all not the Grafana, Prometheus, not the daemon sets. Daemon sets means
This
each.
time saying for the node exporters for each.
Yeah.
Right?
Yes.
So we generally use for the
Logging agents.
Yeah.
implementations.
You know some more, right? Kubelet.
Yeah. Kubelet, proxy.
Kubelet, they named in the AWS is the AWS node.
Node.
All these are all something. So in some companies, I have seen it, they will scan your pods also, pod images as well. So they will install some security agents also to scan. It's up to the company. Security agents also. What they do, they'll scan your pods.
Like ECR.
Exactly. Yeah. Equal to the ECL. Yeah. Yeah. There is some security agents. It's up to the like open source agents are there. So they will run on every node and then they will report that this pod is having something, some kind of vulnerabilities or something in the runtime as well. Cool. So if we say ECR, right? ECR is running environment or storing environment? ECR.
Sorry.
ECR is the imaging storing place or a running place?
Storing place.
Storing place.
EKS?
Running place.
So you can scan images on the runtime also. You can scan images on before also, right? Let's say
Right.
here
Exactly.
the image storing place and the image running place. This image came from where? From the code only, right?
Yeah.
Docker file and all. So
Yeah.
where is the good place? Earlier, what was happening in the old technology, right? They were scanning here only. They were scanning here, everywhere in the runtime only. Now technology came. They are going left, little left, little left.
Shift left.
Exactly, that's where. So shift left is a good keyword. So we will in the DevOps, right? Like till going to the production itself, why to bang that? Like why to take the issues under? They're going before itself. They're scanning here before when you do coding, when you do building image during build image, like here itself during build image also. If image is a vulnerabilities, right? We won't allow people to push also. Docker push also will get restricted. Right now, Docker push we are making, but if we make more security, right? Docker build will happen, but Docker push will not happen because it has a vulnerability, so we can restrict that. So there are some technology going towards the shift left. They're going before itself. They're finding that issues. So just get this is a good keyword, shift left. So like that, security agents also will be there as a daemon sets. Now some daemon sets. Yesterday we have seen it. So STS, the STS numbers will start -0, -1 something. Now how to check which pod is the daemon set, which pod is the STS, how the deployment created it, some kind of pattern, right? So let's see.
Yes.
Let's see here the other one as well. If there are any jobs got deployed something, you can check how to check the deployments.
kubectl.
Describe.
Yeah.
Get pods.
Get yeah.
queue.
Get deployment.
In which namespace we are checking now?
Yeah. -n.
If we want to check how many namespaces are there, first check the namespace.
Yeah. Get NS.
This many namespaces are there. Few of them deleted. I deleted. I mean, it's been removed. Only these are there. Grafana, Prometheus. Applications once we deleted it, and then Ingress. These three we created it. Remaining came by default. Okay. Now, yesterday you have seen some daemon sets they have installed here, Cube system. I want to see what all the deployments are there in the Cube system.
kubectl get
Are in the Prometheus also, kubectl.
kubectl get deployment -n and the Prometheus.
Prometheus.
Deployments. 3 deployments are there. And then I want to see any stateful sets are there in the Prometheus namespace.
Yeah. kubectl describe.
Get. When I say get means always get.
STS. Yeah.
There is a one game, Prometheus Alert Manager. So there is a one command. This command is checking in which namespace?
Prometheus.
You can put -a. -a means all the namespaces.
All.
-a you can use for multiple purpose. I want to see all the pods in my cluster. It will list all of them. You see, right? So many are there here, something. Now you see, right? If any pod like this status na completed something, right? If you see, right? Completed means it's not running. It came and then it went off. So that's mean this is a kind of cron job or job. It's been created up from the let me tell you one more here. This thing na cron job. If I deploy kind equal to cron job, like you remember this guy, you already know it. Kind equal to deployment. Deployment will create internally which objects?
Parts.
One more.
Replica set.
Replica set.
Yeah, replica set and then the pod, right? Same way cron job, you can I deploy directly pod if I wanted?
Yes.
It's unmanaged. If delete's gone. Same way, cron job also will create internally one job like pod, same, and then it will create a pod. This is over here. So I can deploy a job also directly, but if you delete the job, gone. So if you create a cron job, right? Based upon the time and all, the one more job will get created and all here. So cron job will create a job internally, then job will create again the pod. So it's up to the people how they go. Now, if you see like this completed something, these pods been created from anyone this. They could have created cron job or job. So in which namespace you are seeing completed and all?
It's in Ingress Nginx.
Let's go to that Ingress Nginx. Let's see. I want to see jobs. You still get job -Ingress Nginx. See, there are the 2 jobs created. Because of job, who will get created?
Pod.
Pod. What is the role of the job or cron job? On the fly, whenever I needed sometime, pod will come. It will do its action and then it will go for what status? Completed something like this. It will go like this. Jobs will go. If you see any pods like this, completed something, That's mean the parts have been created from the cron job kind or the job kind. That's cool. So like this, you can check any objects in the cluster across all the namespaces. I can check any object. This many deployments are there across, sorry, across all the namespaces. kubectl ds-a, kubectl get ds-a daemon set. So usually, right, if I am not aware of the environment, I wanted to understand the new environment, how many are deployed. I used to use this -a command multiple times, like something to get understanding first. This many daemon sets. Some are in the kube system, some are in the Prometheus. This is the guy is collecting the data. This is the guy is collecting the data, and every node is running, and then he's collecting the pods data, node data. Then it is internally configured in the same namespace only Prometheus server is also running. Then it will send to the Prometheus server. Then we installed Grafana, extra guy we installed. In the Grafana config map, how to check config map? You remember, right? How to communicate from one service to another service. Let's say Grafana dependency who is the Grafana dependency?
Prometheus.
Prometheus.
So always you remember thumb rule. Dependencies will come from the environment variable. Environment variables you can define in the
Config.
.ml stateful set also, but good place to config map, secrets and also. You can check like this also. This many config maps are there. Check the secrets also. I wanted to specifically in that namespace, then I'll put like this. Namespace, that's it. Grafana. So please habituate this, like check the across all the namespaces or specific namespaces. So that if it is a new environment, you will get to know like, oh, this many parts are running, like something and all. Okay, cool. Now, job, you know how the job will come, cron job, you know, to check across the deployment namespaces. Yes. So this is what I was telling. Grafana is depending upon the who? Prometheus, right? So where do we define the dependencies information? You remember this is the get CM. So please observe this. This is the one of the, like, if you want to know about someone deployed it, he left the company, and then you are not aware that, but that is running it. You getting what I mean? They did all the setup, they left the company, or you are not getting the information. This is the good way you can go. If someone already deployed, spaces like a deployment, STS, daemon sets, bots, CM, secret. So now I want to see in the specific Grafana. I told you can define in the deployment MLs also the environment variable, but good place is to config map. You see, right? This is the Grafana. How did we install the Grafana? Prometheus. What is the tool did we use to install? What is the tool I used to install the Grafana on Prometheus? What is the tool? With the tool only we deployed it. I'm giving very good keywords. Deployment tool. What is that? Helm we use, right? Helm. So you can check this also. Helm list FNN Grafana. Same Helm list also you can use for A also. What are the Helm charts we installed with the Helm command? Helm will track this internally. You installed two deployments or two things, not deployment, something, two charts with the Helm command across all the namespaces. One is in Grafana. Cool. So please, what is my objective is get the from existing environment, how to get MLs. I can prepare myself further something. Now, In a specific namespace also you can check get all -n Grafana. In a specific namespaces, what all objects are there? See here. There is a one. Why not ingress? Maybe. Oh, pod is running, service is running, deployment is there, secret is there. Oh, sorry, I'm so sorry. Replica set is there. Secret config map, it is not listing. In this Grafana namespace, you have some objects. CM, secret, deployment, ing, like different we installed. Let's see. kubectl get deploy -n Grafana. One Grafana pod is running. Grafana is depending upon whom?
Prometheus.
Where do we define that info?
Prometheus namespace.
No. Where do we inform to Grafana? Yes, Prometheus is running in the Prometheus namespace.
In every
Config map. In config map.
Config map. Let's check that. Still get CM -n Grafana. There is a one config map is there. Sometimes, right? You cannot duplicate the same resources. See here Grafana is there. Here Grafana is there. This is which object? Config map. This is which object? Deployment. You can have the different objects with the same name, but with the same in the same object you cannot have the two with the same object two names you cannot have it. That's what it means. Now let me check this. This is the command. Please use it every time if you want to know about existing environment. In this namespace, I want to get this config map YAML. Existing, it's not for config map. Any objects you can get YAML. Pass that again. This. Here you can say like this also. Here also you can say. Here.
Using config map, even we can connect part to part.
Yeah, config map only will be used to no. Yes.
So,
In the config map only we will pass other dependency information, right?
Right. Okay.
The config map we will pass to Grafana. Let's see. We'll get to know this. So I'm getting existing environment YAML. -o put YAML here. -o YAML. What is the command I'm running? There is some config map deployed. I want to see that YAML. kubectl get CM like this. You can get this YAML. Like this. This is the YAML has been given to Grafana. This is that. What are these? Which object you are checking here? What is this object?
Config map.
Config map. So if you do normal kubectl get, right, it will say this many, this is the object name. For same, if you put -o YAML, right, that config map name, you will get existing YAML. Whatever we deployed, right, to cluster, that is the YAML you will get as it is. You see here, kind equal to what? Config map. So these are some extra labels you have under metadata, annotations and all that will get added. And here is the name. Let me hide this. You have name, namespace, config map, metadata, name, namespaces. For config map, right, you will get data, not spec. This is
So
what.
this is kind of like cat, right?
Exactly. Yeah, exactly. Yes. You can think yes. Yes. So you see here now, in this config map, somewhere you are giving, which config map you are checking currently here? What is that we are checking?
Grafana config map.
Grafana connects to
Prometheus.
Yes.
this is where you have given that URL. This is where. By taking this internal configuration, this is the configuration. Grafana will load this config map value internally. That we will define in the Grafana deployment only. That also you can check. Can you guys tell me what is the syntax to get the
kubectl
Yeah.
get cm
You getting my question? In the deployment, let me.
okay.
What is the object we have checked now?
But
Config.
we have checked Grafana config map YAML.
Config map. Now, see, like for example, I'll tell you, it's simple. You know already this story. You created a service, you created ingress, you created a deployment. Where are you linking ingress service deployment?
So deployment in service, service in ingress.
In the ingress, where do you define? There is a keyword called backend service something. In the service, there is a section called selector something, right? All are different
Right.
objects. You are linking them with the label matching. Same way,
Right.
now you created a separate object config map, separate object. Who will use the config map?
Pods,
Pods. How the pods are created?
deployment or any.
It's up to that whatever the objects we went.
Yes. Yeah.
It's up
Yeah.
to the objects, whatever we went, this many objects, this many types. It's our this config map information, right? This config map information, we will specify in this YAML. That's what my objective. So
Understand.
you can get that YAML also. If someone deployed, right, you can get that YAML like this. Same story. Previously, you got the config map. Now I want to get the Grafana.
Grafana.
At the end, what is the one you have to append? -o,
-o YAML.
or you can put -JSON also. It's up to that. Whatever it will give the JSON file. It's up to that. Whatever you want. YAML. Yes. You got the. This is the Grafana YAML. How did we deploy Grafana Prometheus? You remember with the Helm chart, but you can get individual YAMLs like this. These individual YAMLs you can modify if you want something. You can, and then we can reuse also. Now, let's go here. We will see something, some configuration. Observe here the known keywords. You know deployment. This is the metadata. Some we will give, some Kubernetes will add, some Helm chart will add. Okay, so just get the keywords metadata. This is all whatever the data you can give. Now, very important guy, spec. How many replicas we are running? One. Setter. This is the strategy, deployment strategy. You see, right? Default deployment strategy. What is there here? Some deployment strategy we call. What is this guy called? What is there here?
Rolling update.
Rolling update. Here is the guy. Here is the guy. Some spec is there. And this is the image. From where the image will get pulled. Here.
Grafana from Docker Hub.
Docker Hub. And you see here, there is a liveness probe. Liveness probe. And one more will be the readiness probe. And these are the ports. I mean, Grafana internally configured to start in the Docker file or somewhere like I mean to say in the application they have started. It's not something at all. So these are the ones, and no resources limited, no CPU, no memory. Somewhere you see, right? Config map, volume owns, Grafana name, config map keyboard, config map keyboard. You see here?
Yeah. Yeah.
What is the config map name?
Grafana.
Grafana. That is what in that Grafana config map you have some configuration. You are giving that to Grafana here to Grafana deployment. This is where you are mapping Grafana something. Different places you can map. Okay, different strategies are there. For now, they are giving as a what here kind of volume.
Volume.
It's not the physical volume. You can bring the config map also as a volume. Secrets also as a volume. Don't think volume is always storage. No. Just they are bringing that config map. Good. So few things important here. We are checking this YAML. You can get this deployment YAMLs, existing YAMLs, and then you can check like this config map. Every. Now, one more guy, secret. All the objects you can get YAML. kubectl. Get secret definite Grafana. Now, previously you have seen config map, right? In the config map, some data, whatever the data you are seeing, right? That is in the plain text format. Text. You can read. Now, one more object I'm seeing. There is a guy called secret. Keeps it will get secret. There is a one object created it. Check this. Grafana secret -o YAML. Same format, it will follow like config map only, but these values, right? Whatever the values, kind equal to secret, metadata, then you will have a data kind, API version, kind, metadata, next data will come. But Kubernetes will take care of that, internally changing here and there. You will not need to worry. Here you see, right? This is the admin user. This is the password. See here. You remember last time we were discussing some information, right? You remember? Dependencies for a application. So application is running in a pod. The pod been created because of deployment. And pod needed dependencies. Like Prometheus, for example. And one more, secrets also. Some secrets, login credentials and all. Login credentials. And all. Okay. All this we will pass here. Here we will pass secrets. We will mount or we will pass secrets, config map. These extra objects we create and then we will give to deployment. This extra config map we will create individually. We will give it to deployment. This is also another ML. All they will link. The pod will load all these configuration and then it will connect. So config map will be plain secret. Secrets is encrypted. You see here, not encrypted, sorry, encode. So you see here, I was telling, right? This you can decode. Secrets is not you no need to have a specific skill set. It's a simple echo. This is the base64 encode. Don't put in the internet. There are in the internet websites are there. Don't put your credentials in the internet. They'll decode, but they'll save as well. Base64, you have to put -d. This is the some credentials. This is some credentials. Next, one more user is there. Same. Echo. This is the admin user. You no need to decrypt all these things. You give the plain value. The Kubernetes will take care of that internally converting into the base64 and all. You no need to encrypt and all. So now you know that from the existing environment, how to get the YAML. Let's say, for example, I wanted for another setup, another environment. What I can do, I can copy these values as it is. Let me do a rough work. I can put my values here. Let it be the same. This and all you can remove, not required. This and all you can remove. This and all you can remove till here. This also you can remove. I can reuse this as it is now. Here I will pass my own things and all. So you should know the technique of like how to make. We don't write from scratch anything. Like we don't type API keyboard and all. Majority times there are the tools in the market like Helm chart and all. You should be using that. We don't type metadata kind of keywords. No, that's not the good practice. Somewhere if syntax comes right, it's better to get from the existing environment, modify it and then apply it. You need to remove some extra components. This is the simple secret kind. Here and there, if you give this ML, Kubernetes will take care. No need to follow that API version kind, no need to that order. It's up to that. Kubernetes will take care. It's up to that order. You get the ML. So that is the individual MLs to get the individual objects. Now, let me ask you the back same question. How did we deploy Prometheus and Grafana?
Using daemons.
By using the tool.
What other tool did we use?
Helm.
Helm, right? Prometheus and
Yeah.
Helm.
Yeah.
What is the command to check what are the charts installed with the Helm?
Film list.
kubectl gets
Helm
List. Film list.
list. Why? I have installed now.
you need to give namespace.
Otherwise, I want to list across all of them.
Default.
-a.
Please, this is the one skill set we used to do normally. Like, see, beauty with Helm is if you deploy multiple versions, like for example, I got some more new image or new chart, something I will upgrade. You can upgrade, right? Inside this deployment in the Helm chart, just I will upgrade one, right? Beauty with the
Yeah.
Helm is it will keep the history. You can check this Helm, how many deployments you did. Helm history, pass that name. How many histories it kept? How many revisions are there?
One.
Let's say if I deploy one, it will keep 1, 2, 3, 4, something it will keep. If you want to, let's say 1, 2, 3 is there, for example, 1, 2, 3 is there. 1, 2, 3 you deployed, there is an issue with the 3. Pods are not running. You want to roll back immediately. Just do one command. Help. Roll back. Something you need to pass this release name. Grafana. Just pass that to just 3, something like this. Just you no need to edit any YAMLs under. Automatically it will revert to the previous chart versions. Automatically it does immediately. You no need to deploy, edit any YAML, no need to do something. Helm will keep the history. This is how it keeps it.
So this Grafana is namespace name, right?
Yes. Which one? Here, -n, right? -n after that is called namespace one.
No. Helm rollback Grafana. Grafana is a namespace name.
No. Here you have to pass it. So,
Oh,
This
this
is
Grafana
the-
is the name of the.
yes, this is the Helm chart name. This is the Helm chart name. Or Helm release name, you can say. Yeah.
Understand.
This is the version. Which version you want to roll back? This does magics, okay? Easily, let's say, for example, someone deployed it like there will be situations I have seen it. Someone deployed in US shift, and then I logged in. Somehow they forgot some, and then in my shift, it's a very critical application. Somehow, obviously, they'll do mistake, and then you no need to do because you are not managing that microservice. Someone is managing it, and then you need to check their code and all that. Instead of that, you can say to the manager, Elm will keep a history. Can I roll back to the previous version? If previous version is good, just run this command. If it is running previously, it will bring as it is that history of the state. All the YAMLs, it will roll back it. Use this one. Keep this. We will deploy our own. We will see. We will roll back to the previous one. Cool. So just keep this. Immediately you can roll back, and then Helm will keep the history like this. Now, this is okay. Now you have seen in Grafana what are the objects you have seen? No, with the YAML. What are the objects you have seen? In Grafana, what are the objects you have seen? What objects we have seen? We were doing something, right? We were checking config map. We were checking one more. What is that? Secret. One more deployment. Now let's see. Some storage objects also are there, right? If you remember, yesterday we were telling something called PV, PVC, storage class, something. Beauty with the sometimes, right, in the Kubernetes, these are all not namespace one. These two. You no need to, if I want to get the PV, I no need to mention namespace. But PVC is the namespace. What do you need to know? In AWS, some are regional, some are global, right? Same way, in Kubernetes, some objects are cluster. Some objects are cluster wise. Among them, these are the cluster wise. Some objects are namespace, like deployment, service, ingress, config map, secret, the stateful set, daemon sets, all are class namespace one. We will deploy to specific namespace. You need to pass -n, but some are cluster wise. You no need to pass. You no need to pass -n. Let's see. kubectl get pv. These are all different namespaces. You see the name itself. It is saying it from which something from where it.
Yeah.
You can guess, right, from where it is coming.
Yeah.
Prometheus.
From this server.
Are you passing -n? No.
No.
PV is nothing but persistence volume. Persistence volume. One more. Let's see. This is also same. This is also same.
Secrets.
Now let's see. Storage class where the original AWS to Kubernetes to bridge. This is the guy is the bridge in between. You remember yesterday I was telling, right? Pod is whose concept? KTS.
Overheads concept.
EBS is whose concept?
AWS.
So, like same way, you have a deployment, you have a pod, you cannot access outside. You need a ingress controller, ingress service. Same way, if I want to bridge between these two, I need some helpful objects. Among them, one is the PVC, in pod, volumes, volume mounts keyword. Please bear with me, you will get to know the keywords. The new keywords maybe. In the pod, we will give, like in the deployment, we are giving config map, right? Same way, in the deployment YAML, we will give like this volume mounts. And extra, you need a PVC. And then one more guy is the PVR storage class. And obviously, one pod is helping us. Something what is that? EBS, something, CSI, something. This pod is helping us to do all these mappings. So we'll just get this keyword. One of the interview question is there, you see, right? Something. This is the guy. How to pod to access? Pod is whose concept? KTS. S3 is whose concept?
AWS.
So that's where this is, I'm correlating there as well. That's what my objective, okay? You need in between some helpful objects to access that AWS resources. Now, to get the EBS volume, you have a PVC, PV, and some of them are cluster wise. These are all namespace one. This is also namespace one. You can check like this. Now, I have not passed for storage class -n. No. Let's check other wala. Get PVC -n. You have to pass mandatory. Otherwise, it will check in which namespace.
Default.
Let's check -n Prometheus. Prometheus. No, it's one more. Very clear here. Two ways you can create the storage class. One is the dynamic, another is the static. Static is you have to manually create that objects and all. Like manually you have to create EBS volume. That ID you need to give to the PV and all, for example. kubectl SC. Here you see right here. kubectl storage class. GPT, GP2 is there. Somewhere you see right here. Storage class GP2. They will match it. What does that mean? These volumes, whatever you are seeing on the screen, these are been created from this concept. Storage class behind. They should match this keyboard. Here is the somewhere storage capacity. Storage capacity. It is there. And you see here, allow volume expansion. If 8 GB gets full, right? If 8 GB will get full, if you need to have a true here, you need to have a true. Then if you edit this, you can edit this PVC. Automatically your volume will get expanded. You no need to touch the AWS console. If 2 GB, 8 GB gets filled, right? This has to be true. This storage class has to be true. This one, allow volume. Here is the one of interview question, you will get it. My volume got full. I want to automatically get increase. So in the storage class, you should have this property equal to true. Then edit this PVC, whoever got filled. Then automatically it will increase it. Okay. Now you see here, how many PVCs you see here? You see someone is using this guy. By seeing this, someone is using, you can say. Who is using this? Which object can be using internally? See this name.
Prometheus.
Yeah.
Stateful set.
No, I was asking the which object you can see. By seeing this one Kubernetes object, it will be using it. 0, 1, something.
Stateful.
Yeah.
Stateful set.
Stateful set. Stateful set will have like this 0, 1, something. Just have this keyword. Cool. So my objective now here is what are the cluster-wise objects? What are the namespace scope-wise object? SC storage class is the cluster-wise. PV is also cluster-wise.
Cluster-wise.
PVC is the namespace one. No need to by heart. When you do hands-on, right, you will get to know this thing. But you keep this thing. Some objects we don't pass -n something. Okay. Cool. So some of them. Now you deployed with Helm. What are the charts you deployed in the cluster with Helm? We deployed some charts no? With the Helm.
Yeah, we have deployed charts.yaml, values.yaml templates.
No, that is inside Helm chart. Yes, so whatever you said is correct. But I deployed some Helm charts here.
Grafana and Prometheus.
Yes. How do you get them? Helm list -a will go across all the namespace one. It's up to. Now, this is the beauty. You can get all the YAMLs. Whatever you deployed in the Grafana, right? You told na in the Helm chart. They could have made one folder, right? These people could have made one folder, na? Grafana folder. Inside that, how the structure will be there?
Again, the same like charts.yaml,
Chart,
values.yaml.
YAML template. Right? In the template, what are all the objects are there? All those you can get. This is the command. What was the command to get normal object YAML? I want to get secret YAML. What is the command we were using? I want to see.
kubectl get SC. kubectl get secret.
Get secret will give
Secret.
the name only, but it will not give the YAML, right?
Yeah, so that you have to pass like kubectl get name and -n, means the namespace and -n.
Yeah, or JSON. It's up to the people. Okay.
Yeah.
No YAML. But in the Helm chart, you deploy here. How many objects you are getting here? Here.
One.
In the Helm chart, you could have deployed multiple, right? You can get all those like this. Helm, get, manifest. Just run this. No need to pass. Helm, get, manifest, Grafana. This, right? You can call Helm chart name or the this guy. What is that guy called? The release name also. You can say. See what are all been deployed. All are coming here. Go little top.
Okay. /service.yaml/
All those in the Helm chart, right? One is the service account. One is something secret you have seen, right? Secret. These are the credentials you have seen. In one YAML, -, you can have it one YAML also, all those like this. Like this. You can get it. One more, PVC. Persistence volume claim we are seeing, right? PVC. And one more, some cluster role. Cluster role binding. And one more role binding. Service. Deployment. We deployed one more, no? kubectl get ing-n Grafana. We deployed this also, right? Why it is not listing here? Ingress, why it is not listing?
It's not inside, and we deployed or like manually.
Yeah, what we followed the AWS document. In the AWS document, they will expose as a load balancer type. But instead of that, what concept we went through? Ingress,
Ingress
our own
control.
ingress control. Exactly. So this is how you can get. Now what I can do in case if I want to reuse this, you can get this file as it is, and then you can deploy to somewhere environment also. Somewhere. Now I want to see what are the values are there. Something I can get it. So you should have this from the existing environment, how to get the setup, get ML, like the kubectl command. If that object deployed with Helm, you can check like this Helm something. So if I want to roll back with Helm rollback. So these are all the you should know that from the environment. Good. So some you remember I was telling some objects are cluster wise, some objects are namespace one. Kubectl get PV or storage class. This has been deployed along with our cluster creation. There was one add-on was there, I think, that has been created it actually. These are all we have not created this GP2 storage class. We have not created it. Along with our EKS cluster Terraform, right? This has been created it. Now, who will use yesterday, right? Let me go here. I have pod. I have EBS volume. So if you want to bridge between these two, pod and EBS, you should have like this. PVC, PVR, storage
Yes.
class. If you go with PV, right, you need to manually create the EBS volume and then you have to define. If you go with the storage class, that automatically will create EBS volume for you whenever your pod will come or something. That's what the thumb rule. So PVC is the what is the PVC object? PVC. PVC is the object will be given to pod. What is the PV? PV is the one who is referring the physical object. PVC is called persistence value. PV is persistence value. Or same storage class also same. This is referring physical device. What is the physical device? Like EBS volume, some NFS. Like it says, where is storage? Storage class also same. It is also same. Can I give PV directly to pod? You cannot give. Can I attach directly pod to ingress? You guys know. Can attach directly pod to ingress. Ingress object select to whom?
No, Ingress object would select service.
Same way. You cannot give directly this guy to here. Pod you cannot give. You need to have mandatory which guy in between?
PVC.
PVC. This pod being created from either deployment or whatever. You need to deployment or stateful set whatever the object. You need to have what is the in between guy mandatory guy? PVC.
PVC.
PVC guy. So let me take some examples in the internet. We will take some examples in the internet. Let's deploy it. So let me go to the AWS console also. And I log in. Let's see. Let's go to the, how many EC2 missions are there? Individual EC2 missions. Let's go. Oh, I created the cluster in that region. Huh? Cluster is in the Mumbai. Autobahn server is here. Huh? Oh, you can access. You need a kube config. That's it. You can access kube config from anywhere, right? No need to be in the same region. I have a kube config, To whom we will be talking in the cluster, EKS cluster?
Pods.
API server, right? So
API server. Sorry, API server.
API
Yeah.
server. Now my objective was I want to see here. You have let's select one guy. Go to some way storage. You have one EBS volume. Oh, one more is there. One more. Let's check the other guy. Two EBS volumes are there. You can attach more EBS volumes also. This we don't touch manual anything, okay? This one is we don't touch anything manually here. Three are here. Somewhere two are here. Usually when you create a EC2 mission, right, you will get one EBS volume only. Whatever you are getting extra in this node, what are running in this node? So which are running?
Pods.
Pods, exactly. So pods need a PVC like this formula. They need a PVC, PV like this, right? They need a this kind of. So some pods we deployed, right? Grafana, Prometheus. They are using the PV PVC concept internally. They are using it. This already because of the Helm chart created for that. Those Helm charts they have defined in such a way that. So when you deploy those Helm chart, automatically PV PVC created some extra volume scheme, and then they are using storage class object, not the PV object. That's where dynamically EBS volume created it here. So normal theory was if you have three EC2 missions, basic theory, you should have three EBS volumes. You can check here. Storage class. You can storage. You can check left side. You have an option here. Volumes also. There are some extra volume scheme. You see here PVC, 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 PVC. How to check PVCs in the cluster? What is the command? How many PVCs are there? Something. kubectl.
kubectl get PVC.
PVC nothing but persistence volume claim.
-N.
This is a namespace one.
Yeah, Grafana.
How much GB it is? 10 GB. This name?
It's 10 GB.
10 GB. And then where is this guy? Where is this guy? Plus console guy. Somewhere 10 GB is there, na? This name. Check this. Select this guy. Somewhere we will. If you want to know more, thumb rule describe. Describe will give more. Grafana.
-.
Somewhere do we get any extra information? Foundation. Somewhere, any clue? My thought was I wanted to get that let's check this. Take this number F0. Somewhere F0. Sorry. Yeah, this is the guy. It is matching here something. Yes, this is the 10 GB. Yes, 10 GB also, but sometimes you can have the equal of the other also. See, this we have not created manually. This EBS volume. How did it is been created? You created one object called which object?
PVC.
Which object?
PVC.
Created one object called we deployed one YAML called PVC. This PVC internally taking somewhere storage class. Somewhere storage class. Yeah, you see here which guy here? Storage class. GP2. You are using PV or storage class concept here. PV, if you say manually, you have to go to the console. Now, automatically that got created means which one you are using, which concept? Storage class.
SC. Yeah.
So this EBS volume, whatever you are seeing on the screen, it's been created automatically by using the storage class. And then we created this with the PVC. The PVC is referring to whom? Storage class. How to check storage class is there or not? kubectl get SC. This is the GP2. Now, tell me now, I wanted to create one volume. What are all objects should exist already? One, EBS volume automatically. I don't want to, one is in the AWS console I can create. but that's not the good practice. You can create, but that's not the good practice. So good practice is to check SC or PV exist, for example, check. What is the command to check? This is the command to storage class. One more command to PV. Here are the PVs are there. Now we are not going with the PV model. We are going with which model right now? Storage class.
SC.
SC is there. Now, what object I want to create one volume. SC is there. But SC is the one who will refer directly to whom? EBS.
EBS.
Create one more object. Which object? Extra object.
PVC.
Create PVC. So how do you create like this example? You need to get, right now. Do you go to the internet? Already you have references. You can get the existing one also, right? However you wanted. No need to depend upon the internet now. You know how to get from the cluster only, right? There are some PVCs are there. Existing. How to check PVCs?
kubectl get PVC -n.
This is the namespace.
Yeah.
Check. Same. -o. YAML.
YAML.
Grafana. You can give this name. Here also you can give it up to that people. Let's see. This is the YAML. Hide floating window. Bring this. Get this YAML. We will deploy it our namespace one. Some custom namespace. Let's remove all these things. Let's remove finalizer. Let's remove all these. Let's remove this also. Let's have this namespace also. Let's remove. And then I wanted, let's say, for example, 100 GB. And then let's remove this one also. Let's remove this. It's all like in the internet also you'll get some sample. Let's get that. Yesterday we had some sample, no? Dynamic, static. If we go here, some website, there was a dynamic, yeah. This is the copy. Access mode, let's remove the storage status. I think you can remove. But in the YAML, right? When you get it from the existing cluster, you can remove status completely. Now, this is both the same persistence volume. Let's make, we'll make MySQL. We'll make MySQL. MySQL. Yeah, let's go with the MySQL one, naming convention. And then, yeah, here they are referring storage class. Here, which storage class we have? Which storage class we have right now?
GP2.
GP2. We'll go with the GP2. Both are same now. Let's go. Create YAML. Now, I wanted to make this one in the Helm chart. Yes, you can make the Helm chart. Here, you have to put that values dot. This also values dot. Something you can call values dot something. So that it will be dynamic. Let's go here. MPD. Save it. Yeah, let it be. MySQL. VA PVC.ml. So you know some objects, no storage objects, storage class, persistence volume, claim, PV and all. So we are giving 100 GB storage class MySQL. Yes. Save this file. Save this file. Cool. So let's create a one namespace called MySQL. Create NS MySQL. NS. Here the MySQL namespace. In this namespace, I want to deploy the PVC. PVC is the namespace one.
kubectl apply -. Name MySQL.
Yes. Now kubectl get. I want to check PVC.
PVC -m.
With the PVC, any pods will run with the PVC. It's a PVC is a virtual object. Okay, it's not deployment. If you ask me, right, deployment stateful set all will create a pods in the nodes. I can say them are physical. For example, some pod will be running in a node, but PVC is a virtual object, a bridge between your EBS volume pod. This is a bridge.
Like service, right?
Exactly. Yes. Yes. Virtual. Yes. 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 because in the interviews I have seen they'll ask you a lot on this guy. Difference between PV and PVC. Here, so right now, it's in status called pending. If you deploy a pod, right, the volume will come automatically. Let's see the previous one. Get PVC, name. Grafana. What is the previous one status? PVC. Here, status was for us pending. Here it is a bound. And then they got a volume, some capacity. This is the storage class. And then write mode, read, write, all those. Some timeline and all. Good. So right now ours is pending. No one is there to consume this PVC. Some part should have it. Let's deploy some example for immediately. My objective was I'll deploy this to MySQL only. We'll bring MySQL pod, one extra pod. Let's see. Do they have? Let's get this on the internet. Voila. Which object I'm going to deploy? Which is the object? Guys, pod object, right? This one. So let's go here. Beauty is this is the one here. This is these three sections. This is the container section. Till here called container section. This is the till here container section. Somewhere you see, right, persistence claim. Can you see here? This name. This name should match with your PVC name. This name. Can you guys tell me here what is our PVC name here? What is the one we deployed?
MySQL.
PVC dot.
This one. MySQL. What was the name? Yeah, that's it. This name. So you are saying to the pod, get the volume from where?
Persistent.
Volume claim. This claim is referring to whom? Internally, to whom it is referring? Storage class. That storage class will bring the EBS volume for us. No. So this is the one you have to give here. Now, very important is, this is you are bringing to pod only. Very important is, this is not enough. If you see thumb rule, if you see somewhere volume, right? Someplace you should have volume mount also. Mount also here. Here. Now, so in this case, right? In this case, they're bringing one image called CentOS. CentOS image. It is writing some data into this path, slash data, like slash home, slash temp, right? Into this place, into here. Now, if you have volume, you should have mandatory volume mount. In this volume mount, this name both should match. This name. And whatever your container is writing the data, that is going here slash data. This is matching your volume. That's where your EBS volume is there. Okay, let's deploy this. It's more story, theory. Okay. For me, important is here. Where are we specifying the claim? That is name. This all you should match it. We will make one internet, MySQL one. You have to be ready with that. So here is the PVC is there. Now let's deploy. kubectl apply for FNN MySQL. Which object did we deploy?
Pod.
Here only it will show. Okay. Now let's check. All are good. And then MySQL. Pod is coming. Pod will run on where? Basic question, but you should be good. Pod will run on worker node. Let's see. If there is any problem with your volume related mapping, right? This pod will not come. This pod will be in pending something and all. It will go. Let's see. Pod came up. Now let's see previous wala. PVC status.
Yeah, it's added.
No, not this guy.
Not Grafana, yeah. MySQL.
I'm sorry. Where is this guy? Where is this guy? Yeah, let's refresh it. You see here?
Yeah. Add
Did we add manually or automatically it came?
automatic.
Beauty is the storage class is the guy, and then one more guy, EBS CSI driver. There are some background components are there. Those are been the helpful guys. Now observe here, the beauty is with this. So, right, I was telling some resources I was saying, right? Namespace, cluster, some in AWS services are zone wise, right? EC2 mission like this. Now, here, right? This guy. This EBS volume is also zone specific. Zone specific. This all are in 1B only.
No, some are 1A. One is only.
1A is there, huh?
Yeah.
Oh yeah,
Yeah.
1A is there. So there is a one problem. If pod comes in other zone EC2 mission, right? If this volume is here, your pod will be having trouble. Okay, that we'll see further. Just now you got it here. Keep it here. You have a EBS volume, SC, PVC, PVC attached to the pod in which section? Volume and volume
Volume
mount. This is the flow. This can be a deployment also, or this can be stateful set also. Okay, this is the story. Good. So now pod is running. If pod goes to running state only. Pod is running. I can go inside the pod also. How can we go inside the pod? Like same Docker exec. kubectl exec7it. You can pass here. You see here for deployment how the name will come. For deployment created pod names, how the naming convention will come. Guys, I'm asking couple of times.
app.
No, deployment created pod names. How the naming convention will come. You should have that mindset. First deployment name will be there. Hyphen replica set. Hyphen some random number will come.
All right.
This is created because of pod object directly.
Okay. Yeah.
You can go hyphen n graph. I'm sorry. SQL. Yeah, I'm inside the pod now. I'm inside the pod. You remember here, we have mounted into EBS volume into one path here. See, right? This is the one. In this path, we mounted slash data. Check in the slash data what is there here. CD. Or you can run one command called df slash. Somewhere, or you can run dff also. dff. Here somewhere you see where is the big size of the disk.
Yeah, there is 99 GB.
This guy, right?
NV. Yeah.
Go slash data. Here you have one file called out.text. Out.text is there. Yeah, some data is coming. So, I mean, it is writing continuously. Now, in theory, right, if pod gets deleted, there is some kind of again is there. If pod get deleted, again I can get this file. I can get this content. Okay. Let's check this wala. kubectl delete -f. Not kubectl get pivo -f. MySQL. Let's delete the pod. Delete pivo app MySQL. My pod got deleted. Let's see the PVC status. There is one guy is there. If we delete the pod, EBS volume also will go. Did we had that condition? It is there. My pod got deleted. Somewhere we will specify that property. That's okay. My pod has been deleted. It's intermitting. No pods. Let's apply the pod. Open it. pod.fn MySQL. You could have got this data, right? Something 3 dot. What is the timeline now? Let's apply it. Check this guy. Data. Time was 350. Something old data 344 and all should be there inside the pod. If there is any issue with the volume mapping, thumb rule, pod will go for pending status 1. If there is no resources, compute, CPU, memory, I mean to say CPU, memory, volume. If any problem is there, if there is no mapping, there is no resources, your pod will go for pending. Thumb rule. That's where you have to describe, you have to find immediately. Now pod came running, all good. Now let's go back to that same exec. DFFNH. Data. Go inside the pod. Date. 351. Still it is updating. 351 it is updating. Now the pod, previous pod has this data. This data. Please bear with me. This is some simple example. We took it. We'll take some good database thing. So 344 and all lines should be there inside this. Do more out.text. 344. See, old data still exists here. This data. After we delete the pod, right? Still this is having the old data also. And then it is continuing with the new data also. Continuing with the new data. This file is getting written. They have written a logic here in the internet example, right? They have written some frequently it will write every 5 seconds. I think yeah, every 5 seconds the file will get right. You see, right? 33, 38, something 5 seconds. Yeah, it is getting updated. So don't care about this output under. For me, objective is the interview point of view, and then theoretically is this. How the EBS volume got created it. This is the guy, the very important guy, the storage class. And then we will not give the storage class directly to the pod. We need to have in between guy, what is the guy? PVC. This PVC we will give it to like this to pod or deployment in the volume here in this section, the volumes. Volumes is not enough in your YAML. You should have one more section called what is the section? Volume mount. So next, we are coming to our custom application. That's where I was bringing all these topics here. So please, my objective here is this is the guy. You should have it very clearly. What is namespace? Deployment. What are the objects in the cluster? When I say objects, please, I'm very specific here. Deployment objects, network objects. You know already these guys. Service, ingress, for example, ingress controller. These are not objects, but you should be aware. And you know all those pods related objects. Very important now, storage objects and environment specific objects. Can you guys tell me here? What are the storage objects? PV.
PV, PVC, SC.
Environment.
Object. Config. Secret.
This you know.
Yeah. That is pod deployment, stateful set, daemon set, and cron job and job.
When you see now how the job came, 0/1 completed something. That is sure it came from the one of these type.
Cron.
You know how to DS. It will run on every node. Stateful set -0 something. Deployment name also you know. So you know, right? All this, whatever you are seeing on the screen. Whatever you are seeing, right? You know, this is what my objective for next, whatever we are going for our custom application. Chalo guys, we'll continue tomorrow. We have session.
I have.
Yeah.
So do you have time to just two queries?
Yeah,
Okay.
yeah.
So, so
can we able to resize the PVC, okay, or the PV, okay, with the manually
Yeah,
after
yeah.
created this PV?
Yeah, we can do that. Yes, we can resize. You have to delete that. You have to delete the pod again. You have to restart the pod to claim that.
So okay, but after created the PV, then we can able to rename it. Sorry, okay, now re-edit it manually, right?
Yes.
There is no problem.
Yes.
Okay, so for next time onwards, okay, if it is deployed via Helm, okay, in
Yeah.
that case, okay, so okay, whatever the amount of space that we are going to increase, that the space has to be updated in the storage
Yes,
class, correct?
yes. That has to be replicated in the MLs as well. Yes.
Okay. So if you uninstall the Helm, okay, so does it does it delete the PVC also?
That's where in your right PVC you can specify one property. If pod gets there is a one property you can specify. If pods get deleted, let's delete the EBS volume as well. That property you can define in
Acha.
the PVC. You have to define it.
By default, it will not delete it, right?
Yes. You have seen, right? I have deleted the pod. EBS volume was still it was there. Right?
That is with the pod, right? Okay, I'm saying about if it is, it's the same behavior with the Helm also.
Yeah. Everywhere.
Okay.
PVC also along with pod. That's where one of the I'll tell you one example. Okay, in my environment, we missed that property. It was running from last almost like 3 to 4 years. We were paying per monthly for EBS ARP on EBS volumes. Like more, someone will
Orphan
take the
EBS, okay.
EBS
Yeah.
volume because right in AWS they'll charge for EBS
Yes.
volumes, right?
Correct.
So ARPAN, no one is using. Someone bring up the pod, they deployed it. See, one way it is dev and all, you can go immediately. This property you can go.
Hmm.
Somewhere you can specify that. No need to define that. Somewhere in your YAML, right? You can define one property. Delete PVC along with pod. Delete claim temp, some property will be there here. Let's go here. In the E, here only you can get the property. Second. Your PVC only, right? Reclaim template, something will be there. That has to be true or something. Something delete PVC. Well, let's for example, there is a one kind of auto deletion. You need to put like this, yes, this kind of when deleted, this kind of one property like this.
Yeah.
One of I was telling it, you have to put one this kind of properties, yes, this kind of one property. Whenever you delete the pod, automatically your volume also will get deleted. Yeah, that can be done. Yeah. Cool. So let's stop it for today. Thank you, guys.